Hi, I am going to talk today about our second day in computational text analysis. I'm going to start with sort of two caveats. The first is that these things are changing really quickly. The things I'm talking about today are sort of the foundation of LLMs and AI, and they are so there's tons of research, tons of things changing and evolving, and hopefully improving in this area. The second is that second caveat is that I don't feel like I'm really an expert in this. I think that I know enough that I think this video will be able to give you some intuitions, some reasonable approaches, and some basic code that should work. But I have not, extensively used a lot of the things I'll be talking about today. I may get some minor details wrong, etc. So take that with a small grain of salt, but hopefully it'll give you enough that you can sort of understand what's possible and have some working code that I think should work reasonably well. So let's jump into it. I'll share this notebook, so you should have it available. So the three things we're going to talk about are topic modeling, word embeddings, and using LLMs to do classifications. The first idea is topic modeling, and so this is you have some set of documents, and a document refers to just any sort of text. So Reddit posts, or congressional records, or survey responses, whatever they might be. And what we want to do is figure out, based on the words that people use, which things are most similar to each other, and put them in groups. So there are lots of ways to do this. One of the real breakthrough in this space was called LDA. But the version I'm going to use is called BERTopic. It's based on BERT, which are pre-trained embedding models. And so the idea behind these, so LDA, one way of thinking about this, at least as far as I understand it, LDA use just the content in the documents and use that to kind of figure out which things were most similar to each other. BERT and BERTopic use a pre-trained model, so it sort of comes with a basic understanding of a language and how it works, and so it doesn't have to learn all of the words. It sort of can put things more reasonably. It sort of can use that pre-training as context for understanding which things go together, and that way if you use a synonym in two different documents, it understands better that that's a synonym instead of just two totally different words. So that's when you're thinking about it. I think it's really cool. I taught LDA for a long time, and really just over the last few years, I've looked into BERTopic. It looks really mature. There's nice documentation, a website, cool visualizations, etc. So I want to show you how to use it. Again, as someone who's kind of new to this myself, but so the thing that I realized after my first version of this is that the default BERTopic sentence transformer has a 512 token limit, so about 300 to 400 words. I'm going to make this a tiny bit bigger so that you can see it. If I can, yeah, hopefully that's big enough that you can see that. For longer things, so there's a few options for what you can do with that. For a lot of documents, that's fine. The first 400 words are pretty representative of the rest of the document, and it will cluster fine. If that's not true, then you can do a few things. One is that they're different, they're longer, they're models with longer context windows. And so that's what we're going to do here. Most Reddit posts are not super long. And so, for example, the one that we use has, 8,000 tokens instead of 500, and so that's longer than most Reddit posts. That's sufficient for our needs. But you may be doing something that's using something that's 100-page documents. What you might want to do is split it into chunks, right? Split it into pages, or 300-word chunks or 200-word chunks, and then you get a topic for each of those chunks, and then somehow aggregate that at the document level. Whether it's choosing the most common topic or treating each document as a mix of topics, which is sort of what LDA does. Okay, so those are the options. You could also use an LLM to summarize it, I guess, into a smaller. That could work as well. Okay, so we're going to load a model. Let me go through the code really quick. So I already did this, but load up. You'll need to install BERTopic. I think you might. I don't know, Python will tell you and give you errors. There might be more you have to install, but if you install BERTopic, and a few other things, ask Google to figure it out. You should be able to run this and import all the libraries. And then, clean that up a little. The thing we're doing is this is the transformer model, the embedding model that you want to use. This is one that has a longer, if I remember right from my Googling, a longer context window, but it's still pretty quick. It's not as doesn't have as many what's the word? Why can't I think about it? Like variables and so it's quicker to embed things. As many dimensions. So that's the idea. It will, I think, this trust remote code, what this does is it will install whichever you've put in here. You can look up different ones. You can look in the documentation for BERTopic to look at that. The next thing it's going to do, this HTTP scan is clustering things. So it's sort of which algorithm to use once you've embedded these documents. That's one way to think about it, is this high dimensional space, and you're putting them where they go in this high dimensional space, and then what do you use to figure out where to draw the circles around where things, which things belong together. So that's what this is doing. I'm pretty sure I just used the defaults. This, whatever was based, like this is mostly based on the documentation from BERTopic. It's worth looking at that. Maybe it's changed, updated. Maybe they have newer, better models. But that's what I've done here. I actually don't even remember what representation model is, but there you go. So they recommended Keybert inspired. What does it tell us? Fine-tuning topic representations. Okay, so there you go. And you can mouse over and it'll explain some of these. There are other options for all of these. Like that's one of the cool things about this is it's sort of like this, you can think of it as like a process, like it embeds and it clusters and it identifies topics, and each of those are configurable. So you can do different embeddings and different clusterings and different topic identification sorts of approaches. It's very cool. It's very cool. It's worth, if you're doing this, it's worth reading through the documentation, but this will give you at least a basic. So let's see if this will work. Hopefully, oh, darn it. All right, let me pause. I'll be right back. Okay, sorry about that. Figured out that anyway, long story short, the sentence transformer that I was using required an older version, which I had when I was testing this code, an older version of the BERTopic stuff. So I switched, this was the one that AI suggested to me. There's also a long one that has long context window. These are pretty big. So if you want, you can look up, it's worth looking. It might also be slow. It's worth looking at the different options for these sentence transformers. It can make a big difference in how quick it is, how much space it takes up on your computer, etc. But we'll use this one for now. We'll see if it takes a ton of time to do this, then maybe we'll switch it. Okay, so we're gonna use the subreddit data. This first line loads it and trains the model. We're gonna pre-compute the embeddings separately. That way we can keep them and reuse them. So this also, again, because it's slow. Oh no, maybe I did the whole thing. Yeah, I don't see a subset. I think maybe I did at one point because it was going slow. But let's see how long this takes. Let's see how it goes. So we'll pre-compute the embeddings. It's starting now. It's going to do 79 iterations, I think. Oh, and it's taking a long time. So maybe that model is too slow. Let's see how long. I think the first one's slower, if I remember right from last time. And then it speeds up after that. But these might be too long. Again, if this is your research project, it can be worth it, right? It can be worth it. You may want to, use a bigger model, etc. There's always going to be trade-offs, and so you'll need to figure out. For the sake of this example, though, I think I may use a smaller model. Yeah, let's do that. This is going to take too long, I think. So I'll pause the video. I'll be right back. Okay, holy cow. So what I did, I switched to this, just to make it quicker for this, I switched to, this is one of the, I think I can make sure of that. Anyway, this is one of the smaller embedding models that is produced by BERTopic. I'm also leaving in this longer context option commented out. So if you want to use something that's going to take you longer but might work a little bit better, you can use this one, which is a really big one. So this is, yeah, I think this is not a problem. I'm not quite sure. I got an error. You might get the same error. It seems like it's working okay. We will see, I guess. And then, oh, it finished. Oh, that's great. It only took 2 minutes to do that, so that was much better. And then we're going to, now that we've created the embeddings, now we're going to create topics from those embeddings. So I'll do dimensionality reduction and then do a clustering. Oh, sorry. Close my... yeah, so there you go. It's doing dimensionality reduction, clustering, and then representation. So it's going to do all of those pieces. And again, each of these are modular, and so you can kind of change how they work. Okay, and then once that's done, I think it's, I don't remember how long that takes. We'll see. I'll pause if it's taking forever. Oh, good. So about 30 seconds for me. And then it creates these topics. So this just shows the topic frequency, right? So the miscellaneous topic is -1. There's about 500 posts in that. And then, you know, about 400 in each. If you remember, we said it had to have at least 25. So that's why there are 17 topics. Nope, 16. Hold on. What is this? I'm not sure what this, maybe it's some sort of initial index, and then it gives it a topic number. Okay, well, whatever. There are 19 topics that had at least 25 documents each. There are a bunch of cool tools on the BERTopic website. I'll show you a few of them. So one visualizes them and how, like, where they are. So this is dimensionality reduction. I don't remember what we used, but, you know, dimension 1 and dimension 2, and it shows you like which ones you can mouse over it, and it shows you which ones. This is, you know, Congress and Trump and Pelosi and counterterrorism. And this one's Senate. It's hard to see necessarily how they all relate to each other. Biden, deportation. A lot of these have Biden, it looks like. COVID. This is sort of old data. I don't remember when I grabbed it. But there you go. So that is, oh yeah, what does this do? Oh, it highlights them. Oh yeah, that's kind of nice. Okay. Another one shows the top words associated with each one. Oh yeah, when I'm zoomed in like this, you can't quite see. But right, topic 0, COVID, quarantine, government, anti-coronavirus. So you can see, right, this one's more about Republicans. This one's, I don't know, maybe. So some of these are quite similar, right? And you can imagine, well, we'll see. We'll see when we look at them closer if they feel conceptually distinct. Like that's one of the things we'll talk about is that, you know, there should be a human element in interpreting these. So, okay. We can look at how much topics are used over time. So, oh, darn it. I'll have to fix that as well. Let's see what I broke. Okay, I'm not quite sure what happened. This looks like it's okay. It's running now. I don't know. If it doesn't work for you, let me know. There might be something wrong with the data, but looks okay. Okay, so that's doing its thing. I think this one might take a little bit. And I actually need to run, so I'm going to pause this, come back to it, and finish the video later. Okay, I am back. That took about 9.5 minutes. So yeah, that one's long. I actually don't know what takes so long about it. I think it does some, if I remember right, it does some kind of, like it takes into account the time when it's, yeah, there we go. Models. Let's read a little bit about it. I think it uses time to sort of figure out topics. Is that right? I don't remember. I think there's ways you can make it faster. If you are interested in this, you should look into it. This is kind of just the basic. Oh, maybe it's the global tuning. Yeah. Fine tune each topic representation at timestamp. Sorry. Maybe if you turn that off, it'll be faster. Anyway, if you're interested in doing it, look into it more. If you don't want to wait, it'll take, then don't do it. It'll take a while. But then it produces this very cool graph, right? That shows, for example, this red topic, which had governor, election, recall, California, and polling, sort of is popular at the beginning of the month. Oh, this looks like it's, oh, there you go. That's when I got the data from September of 2021. And then it becomes less popular over time. Whereas, yeah, I guess similar with vaccines, a lot of the others are similar. Anyway, it's unsurprising that over this short of a time period, we won't see huge differences. But you can imagine, right, if you had a much larger data set over a much longer time period, you might be able to, interpret some of the changes in which topics get talked about. In a paper that we did a while ago, we did a similar thing with LDA topics and sort of looked at how these topics, like things that studied social media, how they changed over time and what topics they were looking at. So there we go. So, but I think it's really important for all of these kind of default approaches. It just shows the top words associated with each topic. I think that if you're doing this sort of approach with topic modeling, you really need to get back into the data and actually read them and not just look at the top words. And so this is one way to do this. You get the document info and save it as a data frame, and then in this case we're getting rid of the -1, sort of the miscellaneous topic. We'll treat that as not meaningful. In this case, I mean, obviously, it means throwing away a bunch of data, which might be interesting. It might be worth looking at it if you feel like you need to, for example, get a true representation of all the sorts of things people are talking about. But this should give us a pretty good representation. So let's do this, and then we'll sort it by probability. So we'll group it by topic, sort by probability, and then give us the top 20 for each of these. So let's just look at this. Usually, right, you would want to do something that, I show an example here of like saving this to a CSV so you could actually read them, especially if it's some sort of long document, you'll want to do that. But let's just look at what this looks like. Oh, come on. Okay, here we go. Oh, that's not helpful at all. All right, there we go. Scrollable, so this is not great. There's a lot of weird spacing and things like that. Again, you probably want to save this as a CSV, but this will give you a sense of like what these look like. How do I scroll to the top of this? It's very long and the scroll bar is very small. Okay, there it is. Okay. So, right, you can see for each topic 4, what is going on here? Okay, there they are. There's one that had a very long line. This is Gavin Newsom's signature homeless program moves to repair old buildings, demise of democracy. So these look like it's a lot about Newsom, a lot about California. Yeah, this looks like the California topic, right? And so you might name it that when you're, doing analysis, things like that. Let's look at one more just to kind of get a sense of how you might do this. If these are all quite short, again, if you have longer documents, you might not be able to look at 20, you might look at 10 for each, but I think it's really important to figure out sort of something deeper about what's going on. So this looks like it's about vote auditing and sort of election fraud. So that's this topic. You can see like these are all quite similar, right? It's really pretty neat how well topic modeling works, and also how important it is, I think, to do this sort of manual qualitative approach at looking into things. So okay, so that's topic modeling. Again, a very brief introduction. I changed this. Oh, dang it. I think I accidentally, this is from an older version. This will be changed. For this exercise, I do want you to do an exercise with this. These are really short, but I think they often work really well with longer texts. So I want you to find some longer texts, maybe from Kaggle, something like that. You could get like papers or abstracts, something that's at least kind of a few hundred tokens, and then look at, see if you could run a topic model on that. So there you go. So I'll change what that exercise looks like by the time you look at it. Okay, the next method is word embeddings. So the idea here is that a word embedding sort of creates this multi-dimensional space. You can sort of think of it, in 3 dimensions, it's sort of like a sphere, but it's many more dimensions. I think we'll do 50 in this example, but you can have many more. But you're sort of putting words or tokens or context into this kind of multidimensional space based on the things that appear near them or are likely to appear together in a corpus. There are lots of cool ways to do this. They are really kind of fundamental to BERTopic, to LLMs, but you can also use them just themselves. So one of the uses I think is really cool is to compare if you have enough text, and we don't really quite for what we're doing, but this is just an example. But if you have quite a bit of text from two different communities, then you can look at, maybe you have, all of the tweets from Republican politicians and news people and all from Democrats, and you can sort of look at how different language patterns correspond to each community, like where in semantic space that something appears. So, a note is that these are unlike BERT, for example, where there's a token is put more in context. These are not context aware in the same way. So study, whether it's study hall or a study is the same and appears in the same place. So yes, okay. So this is word to vec we'll be using. You could also do something like using BERT and sort of use a pre-trained model and then sort of build on it with context from each community, and then use that. That could work as well. I think it seems like it should work. I borrowed most of this code from Laura Nelson's example and built on that a little bit. What we're going to do is look at differences between comments on r/Purdue and r/Indiana. So IU are the Purdue's rival, and so let's see if this will work. Hopefully, okay. So this is just getting the libraries that we'll need. This is tokenizing, so changing things into tokens, splitting by punctuation. And then tokenizing the subreddits. So we'll have these two subreddits, and we'll save them as Purdue data and IU data. So we'll have these two data frames, each with different data. So there's two different, again, we're running into the limits of my knowledge pretty quick, but there's two different main options: continuous bag of words and skip grams. If you plan to use this for your research, you should understand the difference between them, but I will mostly skip past this. You should also understand some of these parameters you might want to play around with. The key idea, at least according to what AI told me, is that using more epochs and smaller vector size can help with a smaller corpus. So like what we have, which it's not a ton of data, and so but you can play around with that with the more epochs, the longer it'll take, etc. So let's run this. I think it's quick-ish if I remember right. So this will give us a vector for each word that appears in the data, as long as it appears. I think that min count is this, as long as it appears at least 5 times. And so it's part of a 50-dimensional, so vector size, a 50-dimension space. And so we can look, for example, at study. This is where study appears for the Purdue data. Right? It's not meaningful. It's only meaningful in the sense that, like, we will look at what appears near it. It should be things that have to do with study or with sports. So we can do things like that. So this wv.mostSimilar says what are the words which are closest in this sort of 50-dimensional space to each of these words, to studying, for example. And so, for Purdue, silly and application and biological and practical and despite and IE and 70 for some reason, and activities. Maybe I studied so hard and I only got a 70. I don't know. Activities, finding, sessions, and at IU, sleeping, eats, PC, bio, enjoyable, 40K, majoring, finish, CS, and connecting. I don't find those super meaningful. I'm sure you could try and pull some meaning out of them if you wanted to. If we look at sports, again, this is older. It might change. My guess is it changes a lot. This sort of thing probably changes a lot depending on when you pull the context from. I'm sure IU and football would be very highly, very close now, but they might not have been, 3 years ago or whenever when I did this. So let's see, Alabama, museum, liquid, soccer, psychology, volleyball, sunsets, women's. Yeah, so there's some, like, why in the world propulsion would be close? I don't know. So some of this is, like, this does not, I'll give a big caveat that this approach really works much better when you have lots and lots of data. I do not have tons here, so that when you're downloading it doesn't take up a ton of data on your computer. It's more a kind of a working example, but it should, in theory, work better and better the more data you throw at it. And as you can see, even with what we have, let's see how big. I don't even remember. Let's see how big these are. Oops. That's what I meant. Let's see how Purdue data. That's probably not what we want, right? What do they call this? Oh, it is. That's the tokenized version. Okay. Let's just look at the DF. Okay, so it is like 24,000 comments. They're all quite short. And so we're getting to where it should be semi-useful, but again, as you can see, the more you have, the better. Okay, so this exercise is pretty simple. Just identify some more things, then see if you can find something interesting in differences between these two communities. Okay, the last thing I want to show is using LLMs for, there's lots of ways to use them for research. I think that we are still figuring out as a community what the kind of norms, what the moral, correct, the morally appropriate uses of LLMs are. I think that there are tons that are, I'm going to show one that I think is very morally okay, and that I think is really useful in a lot of contexts, and that is classification. And so this is where you have some construct that you want to, just like coding. If you've done social science work and you talk about like coding the data, right? You're saying like this data includes anger, or this text includes jealousy, or something like that. There's some construct, psychological or rhetorical or whatever, that you are sort of like binary marking whether or not it is in a given text. And so so LLMs are quite good at this task. They are getting even better. I'm going to show you a simple way of doing this. There are more complex ways. There are libraries that do this, but this works really pretty well. So this assumes that you are at Purdue. If you so this talks about using the RCAC API. If you are a Purdue student or faculty, it's very easy. It's pretty easy, and you can figure out how to do this. This is like a completions. I think it's very similar to like OpenAI's completions. You'll just have to sort of switch out, instead of using the RCAC API, you'll use the OpenAI or Claude or whatever. But most of the code should work pretty well. Okay, so here we go. So what's this doing? It gets classifications. And what we're doing, this is a very silly task, but we're getting all these comments that we have. We want to figure out whether or not a hobby is mentioned. So we want to look at differences in the hobbies people have at Purdue versus at IU. And so we do a few things. I don't even remember what bug I found that resulted in this. I don't even remember that. Okay, well, handling some bug about that sometimes it shows up as tuples. But here's the key part of it, is that we have a message, and then this content is telling the AI what it is. So this is sort of the directions to the AI, right? So you're an AI assistant that's analyzing Reddit comments, etc. I'm going to give you this number of comments, so that's passed right here, right, how many comments it is, and then this is the comments themselves. and then your task is to process each one. So you have this kind of, and you may actually I used an AI to help me to write this. They are very good at that in general. And then it's also an iterative process. So you do some testing, you write your prompt, you test it and see if it's classifying, if it makes sense, if it's working well, and then iterate and change some things if it's not doing what you want. And so here's the comments, and then it's here's your task, what you're supposed to do, AI. It has an ID, comment preview. You're supposed to return reasoning. Oh yeah, this is, so it includes, you're supposed to include the ID, comment preview, reasoning, and a hobby, if there is one, or an empty string if there isn't one. And then it explains what is a hobby. And again, this is really pretty similar to like people coding and then coming back together, discussing differences and figuring out new rules for coding. Is that you sort of do the same thing. You iterate, you figure out, you look at how it's coding things as hobbies. If it's not coding as you want, then you change these rules, right? You sort of work together to figure out rules. So I think I had to add, be generous in interpretation, but don't make assumptions, e.g. going to class is not a hobby, playing intramural soccer is, et cetera, et cetera. And so one of the problems I had is it didn't always return all of the comments or return them not in order. So there's this kind of critical step. Again, this is the result of sort of some iterations. And similarly, make sure it's a valid JSON array. Here's an example. And then it gives, this is what makes it few shot. So 0 shot is that you just give it instructions. 1 shot means you give it one example. Few shot means you give it a few examples, or versus kind of in many cases of classification tasks, machine learning, we give hundreds or thousands of examples to something like a regression model, a random forest model, and then it learns from that to classify others. With these large language models, often just a few is enough. This is another place that you might play around with what types of examples, if it's misclassifying things in the same way over and over again, you could give examples of classifying those correctly, etc. So here's examples of the output, and then begin your analysis. Okay, so and then I did a little bit of error catching, and so yeah, let's try it. Let's run that. Oh, darn it. Okay. Oh yeah, I didn't import that yet. Okay, just a second. I'll fix that. Be right back. Okay, sorry, figured it out. I was just running from the wrong directory. Anyway, got to figure it out. It should work for you. Then let's get classifications. This just tests it, right? Does this work? You can see it's actually not super fast, right? It takes about 4 seconds per classification. There are other options for classifying, like BERT has some classification tools, Roberta, I think. I have not used them much, to be honest, but I know people have that they should be much faster, and probably, depending on the context, can work as well. But these LLMs, as you can see, they're super easy. You really, you have the prompt. It's easy to adjust them instead of doing fine tuning or kind of complex things. You just sort of adjust the prompt, and they can often perform a lot better. So okay, so we're going to look through these. It has the ID, comment preview, test. Okay, so the reasoning is no hobby mentioned, and the hobby is blank. That looks great. ID 1, I love playing basketball at. The reasoning is that it mentions sports. The hobby is basketball. IU has great hiking trails, and the hobby is hiking. That looks good. That looks like about what we want. And so I played around with this a little bit. It may depend on the context, but I found that about groups of 10 comments at a time works pretty well. If that doesn't work, I have a little error checking to get 1 comment at a time. If the batch of 10, if it doesn't return 10 responses, for example, then you can, it'll do 1 at a time. Again, because this is takes so long, you probably want to write out as you go and do so, and then check where you were and start over again, if that makes sense. Things can go wrong. You might have to leave. It doesn't, you can't take it. If it takes an hour or 2 hours, you might have to turn off your computer. for a huge data set, it could take days, right? And so, so you want to do that. I'll show you in a second how you do that. So we're just going to do 1,000 because this does take a while. We'll just do 1,000 comments. You can make this smaller. In fact, maybe we should. So we aren't taking forever. Let's do like 500 comments. Now you can put this higher if you want to see how, play around with it, see how it works. We're going to have turn these into tuples for the comments and the index. And then that's what we're going to pass. So that way we have the index, we can make sure they match, and then we can combine it back again. Okay, so we'll batch them into sizes of 10. So now we'll end up with these comment batches. So that's what we've got now. Oh, come on. Oh, df is not defined. Where did we define it? I had to restart the kernel, so I'm sure that's where the problem happened. We must have done it up here somewhere. Dang it. All right, let's see. There's df. All right, let's just run this really quick. That should hopefully get us there. Oh no, there's more dependencies up above. Cool. Oh yeah, because it's doing all the tokenizing. Okay, that should be fine. This should be pretty quick. So I'll just redo this instead of separating it on its own, which would be the smarter idea. Is there more that's missing? Oh, we didn't even import pandas. Great gravy. All right, let's do that. Yep, there's pandas. All right, we'll import pandas and then come back down wherever we were. There we go. We will hopefully get, all right, there we go. All right, we've got our data frame. Maybe I'll clean that up for you by the time you read this or download it. Okay, so we've got our data frame, maybe. We're going to get our sample. Perfect. We've got our comment batches. And then here's what we're doing, right? So here's the file name. We're going to open it. We're going to see if it exists, right? In fact, I should see if it exists. Did I delete it? Oh, I'll delete it so that so that it'll start from scratch. But we see if it exists. If it does, then we have our hobbies. And that's going to be our first hobbies is this set. Like we'll make a list of all the hobbies. And the length is the number of items in that list. And then we will just skip until we get to that if we've already started. So okay, so our for each batch, our comment batches, we will mark the index for where it starts and ends, and then -1. Oh yeah, okay, yeah, cool. Plus the length of batch. Did I mess something up here? That seems okay. Yeah, okay. That's all right. So we're keeping track of where we are. And then we'll also skip, right? If the batch end is less than or equal to hobbies count, we'll just skip. We'll just loop through until we get to the point where we last left off. We'll also, if skip any that we've started, and then finally it says, resuming at comment whatever. We're processing this batch. So we will, then we'll get the responses from the classifications just like we did in our test. We are going to take this JSON and load it as an actual dictionary, list of dictionaries, whatever it is. Do some error testing, make sure we have the right number. And then if that we don't have the right number, right? If the length is not the length of the batch, or it didn't return, didn't return them as a dictionary for each of the items, then we're going to just get each one on its own and do it that way. Otherwise, and then at the end we'll append. That's right. We'll append to this current hobbies. What am I missing? Okay. Yeah, that looks good. Okay. So we're trying to get the current hobbies this way. Otherwise, the current hobbies. Here's this list. Oh, it returns an empty string. Okay, if it can't load it as JSON. In other words, if it returns, this is one of the errors. That's right. It returns a nan instead of like an empty, not a number instead of an empty string, and so this just changes it to an empty string. It prints the error so we can make sure that that's what's actually going on. And then if it doesn't, if the current hobbies is not equal to the length, then we reset. We do a new empty list, and then we get all of the hobbies individually, and then at the end we've got this list of hobbies, and we write it out to the CSV. Okay, let's see how this works. It takes a while, so I'm just gonna stop it probably. I think it takes something like a second per classification, if I remember right. So it should, I think it was about 10 seconds. No, we're still in batch 1. It might be a little bit quicker for future ones. Oh, I forgot it was printing this. Where is it printing? Let's see. I think it's fine that it's working. Okay, print response text, there we go. So it's printing all of them. You can comment that out, I probably would. But you can see what it's doing at least, and make sure it works, right? No hobby mentioned, no hobby mentioned. Just chores, not hobby. I like the reasoning, some of them are great. And so, yeah, I don't know. It's pretty rare that people talk about hobbies, but you can see, okay, we're at batch 5, and it's been a minute. And so, yeah, something like, a second per classification is pretty close. Okay, so I'm not gonna let it run that whole time. Well, let me show you, just to show how this batch processing works. So like, if I stop it, then I start again, then it should read it and see it's already got me on batch 6. So that's pretty nice, right? It's not gonna redo it, they'll all be there. Yeah, so that works pretty good. Let's let it do one more just for fun, and then I'll just show you what the output looks like. If you wanna let it run, yeah, you should. Okay, so let's see if it even got any hobbies. That's complaining because I stopped it. And then we can put them back in the data set. So here's our original sample, and we're gonna merge it based on the ID that we gave and the index, because we passed that in. So we'll make sure that works. Save it to a CSV if we want. I'm gonna and it looks like none of the Purdue ones had any hobbies, and IU had 8 of the ones that we looked at, which was only like 50. So, and in fact, were they in order still? Let's see if they look like they're in order still when we sampled them. Yeah, it looks like IU were first, so that's why, because we just didn't get far enough. So we could like randomize that if we wanted to, but I'm already taking a sample. So, 1,000 rows? I thought I changed it to 100. Maybe that's the problem. I must have, 500 is what I changed it to. 500 from each. Okay, yeah, that adds up to 1,000. Okay, so you get the idea though, that yeah, you could do something like count the hobbies, or obviously like list the hobbies, or further classify them, or something like that. I mean, this would be this is not a good project, and you shouldn't do this for your project, but you can imagine all the sorts of things that you could classify. Really anything that you can think of that you would have a human coder classify, you could have an AI classify. So there you go. That's brief, very well, probably not as brief as you wish, but a brief introduction to some of these computational text analysis approaches.